Welcome to this video on the topic of linear relationships. In this video, I'm going to show you how you can solve a system of equations using the substitution method. In example 1 down here, we have a system of equations. We have equation 1, this is defined as y equals x plus 1, and we have equation 2. This is defined as 4x minus 3y equals 1. Using these two equations here, we're going to use the substitution method to find definitive values for both x and y. This will be done in about 5 steps. For the first step, what we need to do is we need to pick one of the equations and rearrange it in slope-intercept form. In this instance, I'm going to pick equation 1. Writing this out, I get y equals x plus 1, and what you notice is that this equation is already in slope-intercept form, so it makes our job pretty easy here. Okay, step 1 done. Step 2. What we're going to do is we're going to substitute, in our instance, equation 1 into equation 2. This is going to look like as follows. I'm going to start off by simply stating my equation 2. This is 4x minus 3y equals 1. And then I'm going to use the word let, and I'm going to let my y equal x plus 1, which is the same as my equation 1. Now going to the next line, what I'm going to go is I'll say 4x minus 3, and then what we're going to do is every time we see y, we're going to replace it with x plus 1, because we're substituting x plus 1 in for y, and that's still equal to 1. Alright, so we've done the substitution here. In the next step, what we need to do is we need to solve for our singular unknown in this equation we've just generated. So, solving this, what we need to do is firstly, open up our brackets, remembering that this minus belongs to the 3 here, and that's going to give us, on the right hand side we'll get 1, on the left hand side we still have a 4x, minus 3x, and then minus 3. So minus 3 times x is minus 3x, and minus 3 times 1 is minus 3. Collecting our like terms, the 4x minus 3x becomes a singular x, minus the 3, 1, and then we need to move all of our constants to the right. So I'm going to add 3 to both sides, and what you'll notice is that x is now the subject with a singular constant on the right, so we find that the definitive value for x in this system of equations is equal to 4. So that's step 3. Moving on to step 4, what we're going to do is we're going to substitute in known value to discover unknown. So our known value is x here, which is 4. We're going to sub it into either equation 1 or equation 2 to find the value of y. Now, picking which equation to use, it actually doesn't matter which one you use. You can pick either, but it's recommended to think what one's going to be the easiest to work with. In this instance, y equals x plus 1, or equation 1 will be easier because y is already the subject. So, I simply write out y equals x plus 1. I then say when x equals 4, because that's when x is going to equal 4. We then go y equals 4 plus 1, and thus we find that when x equals 4, y is equal to 5. So we found the second definitive value. Finishing this off, all we need to do is state the answer. So in this case, what we find is that x and y is equal to 4 and 5 respectively. So what we've done is we've found definitive values for x and y within this system of equations using the substitution method. Alright, let's have a look at another example. We have example 2, solve for x and y, and we have our system of equations here. We have equation 1, which is defined as minus x plus y equals 1, and equation 2, which is defined as 3x minus y equals 1. What we're going to do is we're going to solve this system of equations using the substitution method. Now starting off, what we're going to do is we're going to grab equation 1 here, and we're going to rearrange it into slope-intercept form. To move this into slope-intercept form, I need to get the minus x here, and I need to get it on the right hand side. So doing that, I eliminate it from the left by adding x to both sides, and thus what I find is that I get y equals 1 plus x, or in better terms it's x plus 1. So here's my updated version of equation 1. Still equation 1, just in a different form, the form we want to be working with here. Alright, now next step, what I want to do is I want to substitute equation 1 into equation 2. So I'm going to say subbing 1 into 2. I simply state the equation for equation 2. Then I'm going to say let y equal x plus 1. Performing this action, I get 3x minus x plus 1 in brackets equals 1, and I need to expand out the brackets. So there's an implied 1 in front of there. Expanding this out, we get 3x minus x minus 1 and 1 on the right. Then I collect like terms, and I'm going to get 2x minus 1 equals 1. Arranging this such that x becomes the subject, I need to move my constants to the right, so I'll add 1 to both sides, and then I remove my coefficient of 2 by dividing by 2, and thus I find the definitive value of x in this case is equal to 1. Now, since I know x, I can now solve for y. Writing out equation 1, I'm going to go y equals x plus 1, and it's when x is equal to 1. When x is equal to 1, y is equal to 2. So finishing this off, I can therefore say that x and y are equal to 1 and 2 respectively. So our solution to this system of equations here is x equals 1, y equals 2. Alright, let's have a go one more time. Final example. In example 3 here, I'm going to show you how you can solve this system of equations using the least amount of working out possible. So starting off, I'm going to label my equations, equations 1 and equations 2. I always label them no matter what. Next is I'm going to start off with my equation 1 here, and I'm going to rearrange it into slope-intercept form. This will yield the result of y equals 0.5x, take 2, and this is now my new equation 1. Next step is I need to substitute equation 1 inside of equation 2. Writing this out, I'm always going to state when I'm subbing a value into another value. This is so it's clear to the reader so they know what's going on. Opening up the brackets, I get minus 4x plus 16. The minus 4x coming from the minus 8 times 0.5x, and the 16 coming from the negative 8 times negative 2, so double negative makes it positive. Next step, I need to collect my like terms, so 3x minus 4x is negative x, and there's still the 16 and the 11. Taking 16 from both sides, I find that 11 take 16 is minus 5, and then getting rid of the coefficient of negative 1, I simply divide both sides by negative 1, and therefore I find that in this instance x is equal to positive 5. Alright, I've got the definitive value for x, I need to now go in for y. So I'm going to grab my modified equation 1 here, and I'm going to allow x to equal positive 5. This yields a result of y is equal to 0.5. So therefore what I find is that for this system of related equations, the value for x is equal to 5 and the value for y is equal to 0.5. So in conclusion, what we had a look at in this video today was how we can solve a system of equations using the substitution method. We did this by first ranging one of our two equations into slope-intercept form, secondly substituting our first equation into our second equation, solving for the now singular unknown quantity. Then, once we know the singular unknown quantity, we substitute it back into one of our two equations to solve for the other unknown quantity, and after which we simply state what our values are.